Hi, in this lecture we will plot the Bode plots for some more transfer functions. If h of s equal to s, then substitute s equal to j omega. H of j omega equal to j omega. So magnitude is omega and phase is j component, that is 90 degrees. Magnitude in dB is equal to 20 log omega. We will calculate the value of magnitude and phase for different values of frequency. If omega equal to 0.1, then magnitude is minus 20 dB and phase is 90 degrees. If omega is 1, then magnitude is 20 log 1, 0 dB and phase is 90 degrees only. If omega equal to 10, then magnitude is 20 dB and phase is 90 degrees. If omega equal to 100, magnitude is 40 dB and phase is 90 degrees. Omega axis and magnitude in dB, 0.1, 1, 10, 100. So at 0.1, the magnitude is minus 20. So here it is minus 20 dB. At frequency of 1, magnitude is 0 dB. So graph is like this. Here magnitude is 20 dB, here magnitude is 40 dB. And the phase plot is, the phase is 90 degrees for all frequencies because phase function phi is independent of omega. If you observe the magnitude plot, if omega changes from 1 to 10, that means omega if changes by 10 times, then magnitude changes by 20 dB. Okay, so this 10 times is nothing but decade. So the slope of this curve is nothing but 20 dB per decade. 20 dB per decade. If you take another transfer function, say h of s equal to s square, substitute s equal to j omega, then h of j omega equal to minus j omega whole square, sorry, plus j omega whole square. So this becomes minus omega square. So magnitude component is omega square and phase component is minus, that is 180 degrees. So magnitude in dB equal to 20 log omega square. So that is equal to 40 log omega. For different values of omega, we will calculate magnitude in dB and phase. If omega equal to 0.1, then the magnitude is minus 40 dB and phase is 180 degrees. If omega equal to 1, then the magnitude is 0 dB and the phase is 180 degrees. If omega equal to 10, magnitude is 40 dB and the phase is 180 degrees. If omega equal to 100, magnitude is 80 dB, phase is 180 degrees. We will plot the magnitude plot. This is omega axis, y axis is magnitude in dB. We will locate the frequencies 0.1, 1, 10, 100. So the different, this is minus 40, this is 0, this is 40, at 100 frequency this is 80. So if I join all these points, this is the magnitude plot. Similarly, the phase plot is phi in degrees versus frequency. It is 180 degrees for all frequencies because phase function is independent of omega. Let h of s equal to constant k. K is a constant which is independent of frequency. So its magnitude is k and phase is 0 degrees. Magnitude in dB is nothing but 20 log k. So this magnitude and this phase both are independent of frequency. So the magnitude plot is omega and magnitude is 20 log k. This is magnitude. Y-axis is magnitude in dB and phase is 0 degrees. Phase is 0 degrees. Okay. So if I take a different example, h of s equal to k by s. We have studied the Bode plot for 1 by s, correct? The Bode plot for 1 by s is like this, correct? So this is at omega equal to 1 and at omega equal to 0.1 this is 20 dB. At omega equal to 10 it is minus 20 dB, correct? This is for 1 by s, but here the transfer function is k by s. So h of j omega is nothing but k by j omega. So the magnitude function is 20 log k plus 20 log 1 by omega. So this is our previous example. 20 log 1 by omega is nothing but the magnitude for 1 by s. So the additional term that we are getting is only 20 log k. Okay, and just now we have seen that the Bode plot for k is like this. Its magnitude is constant 20 log k for all frequencies and it is adding 0 degree phase. So from now on, if we see the term k, what we can do is we can shift the magnitude plot of this particular 1 by s by 20 log k. So here this is the magnitude plot of k by s, which is shifted by 20 log k units. That means, say if k equal to 10, then 20 log k becomes 20 dB. So in the original plot of 1 by s at frequency of 1, the magnitude is 0 dB. Now for the same frequency 1, the magnitude will become 20 dB. Okay. Again, one more point we will take. In the original plot of 1 by s at frequency of 0.1, the magnitude is 20 dB. Now in the plot of k by s where k is 10, the magnitude will become 40 dB. What we are doing is we are shifting this 1 by s plot up by 20 dB. That is, we are shifting this 1 by s plot by 20 log k, where k in this example is 10. So 20 log 10 is 20 dB. So we are shifting this 1 by s plot up by 20 dB. Thank you.